Ever wondered how to enhance the performance of your .NET Core applications? Well, you're in the right place. Today, we're going to talk about memory allocation, a fundamental process that can greatly impact the efficiency of your applications. We'll explore why efficient memory allocation is so crucial, especially when it comes to high-load scenarios. Then, we'll dive into some powerful strategies to reduce memory allocations. Stay tuned as we delve into some strategies to enhance your .NET Core application's performance. Let's start by understanding when it's crucial to focus on reducing memory allocations. Picture yourself developing high-performance applications like high-frequency trading systems or real-time data processing apps. Here, every bit of performance matters, making memory optimization a top priority. Now, imagine you're working on large-scale applications. Here, even minor inefficiencies can balloon into significant resource consumption. Thus, reducing memory allocations becomes paramount. What about long-running processes? Think along the lines of web servers or background services. These applications run for extended periods, and without careful memory management, you might end up with a gradual increase in memory usage, also known as memory leaks. So, in high-performance scenarios, for large-scale applications, and during long-running processes, reducing memory allocations becomes a crucial aspect of performance enhancement. Now that we know when to focus on reducing memory allocations, let's move on to the strategies. Here are some strategies you can implement to reduce memory allocations in your .NET Core applications. Let's start with the first one, using value types where appropriate. You see, value types like structs in C# are allocated on the stack and can be more efficient than reference types, such as classes, particularly for small, immutable data. This is because they don't require the overhead of a heap allocation, so if you're dealing with such data, consider using value types. Next, let's talk about pooling resources. This is all about utilizing object pooling for frequently used objects to sidestep the overhead of repeatedly creating and destroying instances. You can think of an object pool as a toolkit that your application can borrow from whenever it needs, rather than having to rummage around and create a new tool every single time. This can lead to significant savings in memory and improve the overall performance of your application. Lastly, consider using String Builder when concatenating strings in loops or iterative processes. In .NET, string concatenation can be a costly operation in terms of memory usage, especially when performed repeatedly within a loop. String Builder, on the other hand, dynamically expands the capacity of the underlying character array, reducing the number of memory allocations required. While these strategies can be very effective, it's also important to know when not to over-optimize. Avoiding premature optimization is crucial. Don't sacrifice code readability and maintainability for the sake of optimizing memory allocation, especially when dealing with non-performance critical code paths. Also, for applications with short runtimes or low resource requirements, the benefits of optimization might not justify the effort. Memory management is a delicate balance. It's about understanding your application's specific needs and making conscious, informed decisions about how to best allocate and manage resources. Keep in mind that the ultimate goal is to create an application that not only performs well, but is also maintainable and scalable. That's the true art of memory management in .NET Core. Understanding when not to over-optimize is just as important as knowing when to do it. The first trap many fall into is premature optimization. It's crucial to avoid optimizing memory allocation at the expense of code readability and maintainability. This is particularly true when dealing with non-performance critical code paths. The second scenario where over-optimization should be avoided is in small or short-lived applications. Here, the benefits of optimization may not justify the effort and resources put into it. Now, let's move on to common mistakes. One major pitfall is misusing object pools. While object pooling can be beneficial for frequently used objects, implementing it where it's not needed can complicate the code without providing substantial benefits. Next, beware of overusing value types. While value types can be more efficient for small, immutable data, excessively using them, especially large structs, can lead to performance issues. This is because value types are copied by value, not by reference, which can be costly. Finally, don't ignore the performance of the garbage collector. Overlooking the impact of your memory usage patterns on the garbage collector can lead to suboptimal performance. It's important to understand how garbage collection works in Netcore to write memory-efficient code. Avoiding these common mistakes and knowing when to optimize can substantially improve your .NET Core application's performance. And there you have it, some practical strategies to reduce memory allocations in your Netcore applications. We've explored when to focus on optimizing memory usage, how to do it using value types, pooling resources, and string builder for string concatenation. We've also discussed when not to over-optimize and common mistakes to avoid, such as misusing object pools, overusing value types, and ignoring garbage collector performance. Remember, optimizing memory allocation can significantly enhance your application's performance. Thanks for watching, and stay tuned for more Netcore tips and tricks.